a Deputy Registrar General. Along with his academic activity, he is also doing administrative activity also. His area of specialization is analytical chemistry. He guided 8 research candidates for their doctoral degree successfully, and still 6 research candidates are working for their doctoral degree. He has completed 5 research projects successfully. He has a good collaboration with the Department of Pharmacology USA, Biochemistry and Molecular Biochemistry USA, Laboratory of Protogeolin Signaling and Therapeutics Japan, and so on. Dr. Sadashiva is also a member and chairman for several academic and administrative bodies. He published more than 50 research papers in peer-reviewed national and international journals. He also presented keynote addresses, invited talks in many conferences, seminars, and workshops. Several awards are to his credits, like Indo-US Raman Fellowship Award, VGST Award, Young Research Fellowship Award, Italy, and so on. If he goes on to reading his CV, his time is not enough. I request Professor Sadashiva to address all of you on behalf of the 12th refresher course participants, on behalf of the HRDC, Human Resource Development Center Director, and all the staff members, I welcome Professor Sadashiva to this refresher course. Welcome you, sir.
Thank you, Professor Suresh.
Yeah,
It's my immense pleasure to thank you all. And also at the outset, I would like to thank Professor Suresh for giving this opportunity to share my thoughts about organic materials and its applications. But it is very unfortunate due to COVID, we are not able to share face to face. Anyway, I thank you all. I would like to start
friends are participating here, sir.
Sorry?
Most of your friends are participating here, sir.
Yeah, I can see Manjunath. We have done refresher course together.
Yes, sir.
Yeah.
Welcome you, sir.
Thank you. And also, I'm very afraid to tell about it because it is a very shortage of time to prepare for the presentation because of my, as you told, deputy registrar position means it is very busiest schedule. So anyway, I'm preparing to present organic materials and its applications. This topic is very general topic. Just I'm going to gist about where are the applications of organic materials in nowadays in new trends about organic materials about to replace inorganic elements. Okay. So as we know, organic materials have plenty of applications in various fields like pharmaceutical and sensors, polymers. So very vast applications of organic materials. So before going to study the applications, we need some background of organic materials. So materials are defined in modern chemistry as carbon-based compounds originally derived from living organisms, but now including lab synthesized version as well. Organic materials perform key functions in nature, in drug, and also in technology also. The uses of organic compounds affect our daily life, like in pharmaceutical, medicine, agriculture, and all other aspects of in general life. So organic chemistry is assumed with happening occurred in time when beginning with the Big Bang, when the composition of ammonia, nitrogen, carbon dioxide and methane combined to form amino acids, an experiment that has been verified in the laboratory. Organic chemicals were used in ancient times by Roman and Egyptian as dyes, medicines, and poison from natural sources. But normally, as we know, in ancient days, they have extracted so many organic compounds which were used for medicine as well as various applications, but only recorded the property of the extractant, but not able to resolve the structures. It is nothing but until the 16th century, the compounds were isolated from nature in wholesome composition along with several analytical techniques, then were developed for resolving of molecular structure. Scientists like Vesalius in around 1807 believed that organic chemicals originated in nature may contain a special vital force that directed their natural synthesis, and therefore it would be very difficult to achieve synthesis of chemical in laboratory conditions. So we know the organic milestones. In 1540, Accordas synthesized diethyl ether by the action of sulfuric acid using ethanol, and noticed the ether is an anesthetic property. William Morton later and also Crawford Long demonstrated ether as a surgical anesthetic. In 1770, Turbon first distinguished between organic and inorganic chemistry, with organic being associated with a chemical derived from living things and containing property called vitalism. In 1858, Holler, by synthesizing urea from inorganic ammonium cyanate, and disproved the vitalism concept, that is nothing but compounds derived from a living plant or animal contained a special characteristic called a vital force, that led to redefining organic chemistry from the chemistry of compounds derived from the living to compounds containing carbon and hydrogen, and later to compounds of carbon. Also, his experiment was one of the first demonstration of isomerism, means ammonium thiocyanate and urea. He also one of the first to initiate the concept of functional groups. In 1856, William Henry Perkin, he attempted to synthesize quinine, serendipitously synthesized morphine, and had a successful career dye synthesis. Means this is the first dye synthesized in 1856 by Henry. Later on, because of this origin of polymer science has been attributed to many different people. John Wellesley has been given a credit for preparing the first synthetic polymer in 1839. John Edward Simon accidentally prepared polystyrene. In 1909, Leo Baekeland synthesized bakelite. Hermann in 1920 was the first to properly characterize the polymers as macromolecules. Next, Renitizer observed the first liquid crystal, the cholesterol benzoate. Otto Lehmann published a paper on the properties of liquid crystal. So these are all important milestones to enter the organic materials from normal application to new trend applications like liquid crystal with respect to LED or light emitting diodes, and also we replaced semiconductor from inorganic material to organic material. These are all important milestone to come across new trends in organic molecules. The importance of vital and supportive aspects about the structure of organic chemistry initiated with a theory of bonding called valence theory developed by Kekule and colleagues around the late 1850s. Organic chemistry advanced into a dynamic and simulating science in the 19th century. Many new synthetic methods, reaction mechanisms, analytical techniques, and structural theories have been developed. Concerning to the end of the 19th century, much of the information of organic chemistry have been prolonged to the study of macromolecular biological systems. So based on these organic materials, we classified into main medicinal, organotronics, and miscellaneous based on application of organic materials in medicinal, pharmaceutical, cosmetics, healthcare, food and nutrition. Very importantly, organotronics means here we have replaced so many inorganic metals into organic materials in organic light emitting diodes, organic lasers, sensors, solar cells. In miscellaneous means the remaining applications, agro, petrochemicals, automobiles, corrosion. So these are all important classification what we are using organic materials. So first we are going to see the application of organic materials in medicinal chemistry, in pharmaceutical drug discovery. Medicinal chemistry mainly deals with the identification, synthesis, and the development of new chemical entities suitable for therapeutic use. Studies in pharmacology, toxicology, microbiology, biochemistry, biophysics, molecular biology, etc. Pharmaceutical chemistry is to do with the discovery, the development of a new and better drug through organic synthesis, analytical study, and some physical characterization. It involves, means medicinal chemistry involves organic synthesis, complete analytical characterization, including spectroscopy, identification of physical and chemical properties, computational analysis, combinatorial approach, etc. Synthesis of compounds which could show biological activity as a drug, structural identification, study of structure-activity relationship, mechanism of action of drug molecule. In drug designing, we know very well, first we have to synthesize organic materials. Further, we are going to check the activity of the molecule. If we get a potential molecule, then we are going to apply for pharmaceutical field. So before going to synthesize any organic molecule, we need the background of pharmaceutical basics, because if we know the proper site, either in proteins or any mode of action, we need to design the drug. After designing the drug, then we can enter into the laboratory and the designed drug can be synthesized. So drug is any substance which is used for treating, curing, or preventing diseases in human beings or in animals. It may also be used for making a medical diagnosis or for restoring, correcting, or modifying physical functions. The role played by organic chemists in pharmaceutical industry continues to be one of the main drivers in the drug discovery process. Objective of medicinal chemistry is to design and production of compounds that can be used in medicine for prevention, treatment, and cure of human or animal diseases. Taken in retrospective sense, medicinal chemistry includes study of already existing drugs, of their pharmacological properties and their structure activity relationship. First, drug interact with the molecular target in the body, and so it is important to choose the correct target for desired pharmaceutical effect. In other words, a drug that will interact as powerfully and selectively as possible for that target is known as pharmacodynamics. Secondly, a drug after administration has an ability to travel through the body in order to reach its target is known as pharmacokinetics. Nowadays, nanomedicine research played a significant role in drug discovery. Generally, nanomedicine is a field of medicine to facilitate the information tools of nanotechnology to the prevention and cure against several lethal diseases. Example, microbial, malarial infectious, HIV, TB, cancer, etc. Drugs may be classified according to their origin. If we extracted the drug molecule from natural compounds obtained from both plant and animals, example, vitamins, hormones, amino acids, antibiotics, alkaloids, glycosides, etc. Synthetic compound, either purely synthetic or synthesis of naturally occurring compounds, because we know very well about to extract any natural compound, we need lot of solvents and also laborious work. To avoid this laborious work, we may design to synthesize natural compounds. So semi-synthetic compounds also there. Semi-synthetic means we can use any naturally extracted intermediate and synthesize final molecule using this intermediate. So some compounds either cannot be purely synthesized or cannot be isolated from the natural sources in low cost. Therefore, the natural intermediate of such drug could be used for synthesis of desired products. Example, penicillins and also semi-synthetic penicillins. So in organic materials application towards pharmaceutical, we need different steps. First, we design a molecule, which molecule is a potential or not. If potential drug is there, then we enter into quality assurance and quality control. So after study the characterization and everything, after QC and QA, we will enter into pharmaceutical field. So to study the pharmacokinetics, pharmacodynamics, everything we are going to study. So these are all different examples. Presently we are using drug molecules which were synthesized in the laboratory. So also we use organic material in sterilization. So we know very well sterilization is the process that remove all forms of life and other biological agents like prions present in a specific surface, object or fluid. Sterilization can be achieved through different ways by using heat, chemicals, radiation, high pressure and filtration. So in our cases, what type of chemicals we need to synthesize or prepare for the sterilization. Sterilization is a distinct form of disinfection, sanitization and pasteurization. In those methods, reduce rather than eliminate all forms of life and biological agents present. After sterilization, an object is referred to as being sterile. Particularly nowadays in COVID situation, we use a lot of solvents, means ethanol solvent for kill all germs or bacteria or viruses. So it is nothing but organic chemicals. It should not affect on our health. Other than alcohol, if any poisonous solvents are there, for example, chloroform and other carcinogenic solvents, it will be affected on our health. So to avoid all these problem, we need poisonless and also should not affect on our health. So such type of sterilizing solvents we need. Immediately it should vaporize and also it should disinfect the virus in our hand or in our any part of our body. So chemical sterilization, what are chemical sterilization we are used presently? Ethylene oxide, nitrogen dioxide, ozone, glutaraldehyde, formaldehyde solution, hydrogen peroxide and peracetic acid. So organic materials we also use in food and nutrition. Essential nutrients like carbohydrates, proteins, lipids, vitamins, minerals and water. The primary functions of carbohydrates we know very well in the body are to provide energy, store energy, build macromolecules. It improved fuel for the central nervous system and energy for working muscles. They also prevent proteins from being used as an energy source and enable fat metabolisms. Carbohydrates are important for brain function. They are an influence on activity, memory, etc. Fiber is an important part of healthy, balanced diet. It can promote a good bowel health, reduce the risk of constipation, and some forms of fiber have been shown to reduce cholesterol levels. Carbohydrates break down the fatty acids and preventing ketosis. So these are all examples of organic materials which are using which are applicable in diets, means in food and nutrition, sucrose, lactose, starch, cholesterol, etc. So these are all example for vitamins. So we know very well vitamin C, it is a highly antioxidant. These are all different vitamins. Some vitamins can form naturally and also we can synthesize in laboratory. So these are all amino acids. We know very well about all these things. So very important applications of organic materials, polymers. Organic polymers are macromolecules composed of many repeating monomer units. Both synthetic and natural polymers play a crucial role in everyday life. Polysaccharides, polypeptides, and polynucleotides are the main type of biopolymers in living cells. Organic polymers are materials that essentially contain carbon atoms in the backbone, whereas inorganic polymers are polymers with a skeletal structure that doesn't include carbon atoms in their backbone. Some of the biodegradable polymers blend have been developed for the degradation of the packing materials. Polymers directly extracted from biomass like proteins, lipids, polysaccharides. Polymeric materials synthesized by classical polymerization procedure such as aliphatic aromatic copolymers, aliphatic polyesters, polyactides, aliphatic copolymers using renewable bio-based monomers such as polylactic acid. Polymeric materials produced by microorganisms and bacteria like polyhydroxyalkanoates. These are all examples for organic polymers. Examples of inorganic polymers include silicone, polysiloxanes, polyphosphorescens, and polysilanes. On the other hand, examples for organic polymers include low-density polyethylene, high-density polyethylene, polypropylene, polyvinyl chloride, polystyrene, nylon, Teflon, and thermoplastic polyurethane. So these are all different examples which are presently using organic materials for constructing polymers. Inorganic polymers are widely used in petrochemical industries, while others such as silicone, rubber are used in construction of for window and door seals. Also in electric engineering, inorganic polymers such as silicone, rubber is used in wire and cable jacketing and in electrical safety stringer cover. Other inorganic polymers such as polydimethyl siloxanes are widely used as versatile ingredients in many skin care and beauty products because of its ability to serve as an anti-foaming agent, skin protectant, and conditioner. Organic polymer have wide variety of uses. For example, polystyrene resins are used in the production of home electronics and appliances. Nylon 6 is used in textile and plastic industries. Organic polymers such as polyethylene, tetraphthalate are in the manufacture of popular PET bottles. Other polymers such as neoprene are used in shoes and wetsuits, polyvinyl chlorides in pipes, and Teflon in non-sticky ponds. A representative, non-exhaustive list of applications of organic polymers: clothing, sportswear and accessories, electronic and photonic technologies, packaging and containers, paint, glues and lubricants, automobile parts, household items, medicinal applications, personal hygiene and healthcare security. Why I am mentioning all these applications? When compared to inorganic polymers, organic polymers is less poisonous and also economically feasible. Degradable polymers will be helpful to dispose the polymers compared to inorganic polymers. So further, another applications of organic materials in insecticides and fertilizers. So as we know, insecticides are substances used to kill insects. Insecticides are used mainly in agriculture. They claimed to be a major factor behind the increase in 20th century agricultural productivity. Example, DDT, organochloride, runoff, and percolation. Disadvantages: some insecticides kill other creatures in addition to those they are intended to kill. For example, birds may be poisoned when they eat food that was recently sprayed with insecticides, or when they intake an insecticide granule on the ground for food and eat it. Naturally derived insecticides, these are extracted from plants: caffeine, citral, menthol, neem, and nicotine. So these are all organic fertilizers, are derived from animal matter, animal excreta, human excreta, and vegetable matter. In contrast, the majority of fertilizers used in commercial farming are extracted from minerals. These are an example. Presently, we are using organic materials for fertilizers. So another important applications in dyes. Dye, as we know very well about, dye is a colored chemical compound which, when applied to the fiber, must be capable of being fixed to the fiber and give a permanent color. The dye must be chemically stable so that the color will not wash with soap and water or fade on exposed to sunlight. So we know the theory of dyes, chromophores and oxochromes. The color of the organic compound is due to the presence of certain multiple bonded group called chromophore. Example: nitroso, nitro, azo, and quinoid. Another oxochrome, certain groups doesn't produce color themselves but are able to intensify the color when present in molecule together with a chromophore. Such groups are called oxochromes. Example: hydroxy, amine, NHR, and sulfur group and carboxyl group. So these are all different dyes which presently we are using in the dye form. So azobenzene, so these are all different: malachite green, indigo, alizarin. These are all different dyes. So applications, features and applications of dyes. Following are the few common features and applications of color dye used in industries. Dyes are widely used by industries for inks and tinting. Dyes are used by textile industries for cloth coloring and dye lasers. They are free of heavy metals, particularly organic materials. Organic dye, importantly, avoiding heavy metals like lead-free dyes. So they are also used in cosmetic stuff. They are resistant to heat, resistance to UV light. This is very important. In cosmetics, if we use any organic materials, to avoid the absorption of UV light also, and also importantly conducts electricity. In cosmetics, any of several preparations that are applied to the human body for beautifying, preserving, or altering the appearance, or for cleaning, coloring, conditioning, or protecting the skin, hair, nails, lips, eyes, or teeth. So if we use any inorganic cosmetics or any effect on our skin, definitely it will be problem with our health. To avoid all these adverse effects, we are going to replace the organic materials. So these are all presently using cosmetic organic materials. So sodium hydrogenate, high capacity of water holding, and alkane triols and alkane diols for blended into cosmetic product as a moisturizer. So smoothing agent, glucosamine hydrochloride, and whitening agent, kojic acid, and then sunspot and freckle removal agent arbutin. So these are all UV absorber. As I mentioned before, UV absorber, this methoxycinnamate is a very important organic material presently using for UV absorber. And air dyeing, it is also very one of the important application in air dyeing agents. So in petrochemical applications, in chemical products derived from crude oil and natural gas, these chemicals are extracted during the refining process when crude oil or gas is distilled or cracked. Some of the primary petrochemicals obtained in this process include benzene, ethylene, propylene, and toluene. Naphtha is the most important feedstock for petrochemical industry. Approximately 5% of oil and gas consumed each year is needed to make petrochemical products. Petrochemicals can be roughly divided into olefins and aromatics. So aromatic compounds include benzene, toluene, and xylene, from which polystyrene, synthetic resins, and polyester are obtained, among other things. Applications: 99% of plastics are created from oil and natural gas, with most being manufactured using naphtha feedstock. Naphtha is created during the distillation process and is heavier than gasoline. It is one of the most important of all the petrochemical simply because it is used in the production of plastic. Other important petrochemicals included ethylene, used in paper, consumer electronics, detergents, footwear, adhesive garbages, camera films, milk crates, etc. Propylene used in paints, furniture, textile, pharmaceutical, and food packaging. Benzene creates pharmaceuticals, furnitures, electronics, and food packaging. Toluene, inks, and sports equipments. Organic materials also used in lubricants. As we know, lubricant is a substance, usually organic, introduced to reduce the friction between the surfaces of mutual contact, which ultimately reduces the heat generated when the surfaces move. It may also have the functions of transmitting forces, transporting foreign particles, or heating or cooling the surface. The property of reducing friction is known as lubricity. So, important organic material using in lubricants, polyalpha olefins. So another important application, as I mentioned earlier, this is one of the important applications of organic materials in organotronics, means totally inorganic, just like inorganic semiconductors, silicones, and other semiconductors replaced by these organic materials in all organic light emitting diodes, lasers, sensors, and solar cells. Effectively, presently we are using organic materials. So advantages of organic materials against inorganic materials: lightweight, mechanically flexibility, chemical modification possible, easy and cheap processing, low power consumption, high efficiency. These are all examples for using materials for organic semiconductors. Organic semiconductors are solids whose building block are pi-bonded molecules or polymers made up of carbon and hydrogen atoms and heteroatoms such as nitrogen, sulfur, and oxygen. They exist in form of molecular crystal or amorphous thin film. In general, they are electrical insulators but become semiconducting when charges are either injected from appropriate electrodes upon doping or by photoexcitation. The basic solid state properties of organic semiconductors are very different to their inorganic counterparts. They are formed of organic molecules or polymers which are bound by the rather weak van der Waals interactions. Consequently, the intermolecular electronic coupling is weak, resulting in a typical much lower electron or hole mobility than observed in the inorganic semiconductors. Further, the dielectric constant of organic semiconductors is much lower than that of inorganic semiconductors. Therefore, the Coulomb interaction between electrons and holes is much stronger, leading to high excitation binding energy and rather challenging descriptions of electronic properties. So these are the similarities between inorganic semiconductor and organic semiconductors. In an inorganic semiconductor, we know very well valence band and conductive band. Similarly, in organic semiconductors, HOMO and LUMO, so energy gap also using for the semiconductors. So organic compounds conduct mainly due to delocalization of pi electrons. The word delocalization means the property of organic compound by which electron and holes move in conjugated system to attain stability when an electric field is applied across them. Organic semiconductors contains HOMO and LUMO, which are analogous to valence and conduction band in inorganic semiconductors. The electricity is caused due to transfer of electrons and photons from HOMO to LUMO. Organic optoelectronic devices such as organic solar cells, light emitting diodes, organic photodiodes, and organic field effect transistors have been employed successfully for more than 1 decade. So materials, what are materials we are going to use in organotronics? So produced by operation of a spin coating, they have been investigated for device applications such as OLED, OFETs, and OSCs. Illustrative materials are C60, phenyl C61 butyric acid, methyl ester, and pentazine, carbazoles, and phthalocyanines. Molecularly doped polymers are prepared by spreading a film of an electrically inert polymers. Example, polycarbonate doped with typically 30% of charge transport molecules and on a base electrode. Typical materials are the triphenyls. Molecular crystals. Early days of fundamental research into organic semiconductors, the prototypical materials were freestanding single crystal of the acene family, example anthracene and tetracenes. So, organic light emitting diodes are solid state device composed of thin film organic molecules and create light with applications of electricity. OLEDs are solid state devices composed of a thin film of organic molecule that is 100 to 500 nanometer thickness. They emit light with the application of electricity. They doesn't require any backlight, that is, they are self-emitting. They are made from carbon and hydrogen. OLED can provide crisper displays on electronic devices and use less power than conventional light emitting diodes or liquid crystal light. Organic light emitting diodes devices have received much attention because they are exempted to be next generation displays and light sources, lightweight and flexible organic materials. So this is the structure, the principle and functioning of organic light emitting diodes.
Voice. May you mute your voice? It's disturbing.
Can you hear me? Can you hear me? Is there any problem with my voice?
Yes, sir. Some disturbance is coming from Mehboob. Some disturbance coming. He didn't muted his voice.
Ah, is it so?
Yeah.
Now it's okay?
Continue, sir.
Can I continue? Yeah. So, the working principle of organic light emitting diode, an electrical current flows from the cathode to the anode through the organic layer. The cathode gives electrons to the emissive layer of organic molecules. The anode removes electrons from the conductive layer of organic molecules. At the boundary between the emissive and the conductive layer, the electrons find electron holes. When an electron finds an electron hole, the electron fills the hole and then it falls into the energy level of the atoms that's missing an electron. When this happens, The electron gives up energy in the form of photon of light. That is, organic light emitting diodes emits light. The intensity or brightness of light depends on the amount of electrical current applied. The more current, the brighter the light. So these are all important applications of organic materials used in OLED. So in 1987, quinolines, complex of aluminum quinoline. Later, we entered into the polyphenylene vinylene. Next, Motorola used this molecule as the OLED lights. In Sony, also used these molecules to use OLED TVs. So you can see the updated. Earlier we need monitor cathode ray oscilloscope, means big one. Later PDP TV, then LCD TV, then OLED TV. So OLED is a very thin and sharp picture can get using this organic light emitting diode materials. So that in OLED, greater view angle, high contrast, faster response time, do not require backlighting. So in LED and LCD, limited view angle, low contrast, slow response time, require backlighting. So advantages of organic light emitting diode: thinner, lighter, and more flexible, do not require backlight lights, can be made to larger size, high resolution. So disadvantage: expensive, lifespan, water damage, color balance issues. So these are all organic materials presently using for light emitting diodes. So in laser technique also we are going to use organic materials. So organic laser diodes use carbon based organic materials to emit light instead of the inorganic semiconductors such as gallium arsenide and gallium nitride used in traditional devices. So this is the working principle in laser light. Organic lasers use an organic materials as the gain medium. The first organic laser was the liquid dye laser. These lasers use dye solution as their gain media. Organic lasers are inherently tunable, and when configured as optimized multiple prism grating, laser oscillators can yield efficient single transverse mode and single longitudinal mode emission with laser line widths as narrow as 350 megahertz. So this is the absorption and spontaneous emission technique in laser working principle. Solid state dye laser, organic semiconductor laser. Solid state dye laser are organic tunable lasers that use variety of organic gain media such as laser dye doped polymers, laser dye doped armosil, and laser dye doped polymer nanoparticles. DDO and DDPN gain media are subsets of a larger class of organic inorganic hybrid materials used as a laser matrices. Other types of solid state organic lasers include the organic semiconductors, lasers that use conjugated polymers as gain media. These semiconductor materials can also be configured as a neat film. Coherent emission characterized via high visibility, double slit interferograms, and near diffraction limited beam divergence has been reported from electrically pumped coumarin dye-doped tandem OLED devices. So organic solid state narrow line width tunable dye laser oscillator using a dye-doped polymer as a gain medium. So another important applications of organic materials in batteries. So we know very well battery is a device consisting of one or more electrochemical cells with external connections for powering electrical devices. Italian physicist Alessandro Volta described the first electrochemical battery, the voltaic pile, in 18th century. So the material which were used in batteries: zinc carbon, zinc chloride, lithium, and mercuric oxide. So now we are we are replacing these inorganic materials to the organic materials in the batteries. An organic radical battery is a type of a battery first developed in 2005 by Japanese corporation. Radical batteries rely on a redox reaction of an organic radical to generate an electrochemical potential, mainly nitroxide radical. So this is schematic diagram for discharge and charge in the organic material batteries. Organic radical batteries are much more environmentally friendly than lithium ion batteries because organic radical batteries do not contain any metals that pose the problem of proper disposal. Organic radical batteries are non-toxic and non-flammable and do not require additional care when handling. Burning nitroxide radical polymers yields carbon dioxide, water, and nitrogen oxide without ash or odor. ORBs have a theoretical capacity of 147 milliamp hour per gram, which is slightly higher than that of lithium ion batteries with 140 milliamp hour per gram. ORBs also show comparable charge times and a retain of charge discharge capacity well, matching lithium ion batteries at 75% of their initial charge after 500 cycles. Additionally, radical concentration in ORBs are stable enough at ambient conditions to remain unchanged for over a year. So these are all the different organic materials using in batteries: carbonyl compounds, nitrile compounds, organic radicals. So as changing the technology and applying the research concept with respect to organic materials, presently we are using efficient materials in batteries. So this is the applications of organic materials in batteries. Next, another important applications in solar cells. So solar cells is an electrical device that converts the energy of light directly into electricity. So we know the history of a solar cell. So these are the important organic materials presently using in solar cells to increase the efficiency of solar cells. So organic solar cells have garnered much attention thanks to their lightweight, flexibility, and unprecedented energy to weight ratio of 10 to 20 watt per gram, which make them a promising candidate for space applications, although their radiation stability is still poorly understood. Carbazole containing conjugated polymers, high radiation stability, and retaining over 80% of their initial efficiency after exposure to 6,500 giga of gamma rays, a dose that near Earth orbit satellite are estimated to receive during 10 years or longer. So benefits or advantages of organic solar cells. Organic solar cells are 1,000 times thinner compared to silicon solar cells. It is light in weight. It is a semi-transparent. It is eco-friendly. It is cheaper and flexible. It offers a short energy payback time. It is easy to integrate. New organic solar cell set efficiency, world record presently 30% efficiency. So in sensors, we know sensor is a device, module, machine and subsystem whole purposes is to detect events or changes in its environment and send the information to other electronic devices. So applications in sensors to detect blood glucose level and also to detect alcohol content. We use sensors. So these are all important organic materials used in sensors. So these are all important applications in sensors. Finally, another important application, corrosion inhibitors. Corrosion is the deterioration of materials by chemical interactions with their environment. The term corrosion is sometimes also applied to the degradation of plastics, concretes, and wood, but generally refers to metals. So this is the application of organic materials to inhibit the corrosion. Corrosion inhibitors are inert chemical components that form a thin protective film on the metal surface through the adsorption process and inhibit the electrochemical reactions leading to corrosion. The applications is a unique strategy to slow down the corrosion reaction in aggressive acid solutions. Polymer coating applied on a metal surface prevent its corrosion due to separation of the metal form the electrolytes and form other metal parts. There are many well-established polymers for coating applications like urethane, polyvinyl chloride, acrylic, epoxy, silicones. Actually, silicones come under inorganic inhibitors, phenolic resins. So we know very well in ancient days used corrosion inhibitors. Example, we have very good example, Qutub Minar. I think you know very well another picture, non-rusting 2300 year old in Kollur. When Shankaracharya visited to Kollur, that tribe people constructed this pillar. Yeah, actually everywhere they show only Qutub Minar temple, but very less people know about Kollur pillar. So these are all different applications of organic materials used in different fields. So actually until now I have explained or I have given the information what I have collected from the internet only, because my research field come under chemical biology. So actually we, being a chemist, we synthesize small organic molecules after characterizing and check the efficacy, we will apply for biology. So these are all important applications. So from our laboratory, we have done different types of biology: antibacterial, anti-malarial, anti-cancer, antimicrobial, anti-tuberculosis, and anti-tumor. So these molecules normally we synthesize in different either in known method, and also some methods we have developed facile methods to synthesize these molecules. Thank you. If you have any questions from participants, please.
Sadashiva sir, very nice talk to you.
Yeah.
Very nice talk. In your busy schedule, making time and come to here, and you shared your knowledge with us. Thank you very much. Behalf of all participants and HRDC Mysore, I'm very much thankful to you, sir.
Yeah, thank you so much, Manjunath. Really, I'm very happy to see in virtual
Thank you,
interactions.
Okay, sir.
Is there any other participants we know before?
Sir?
Only Manjunath and
Sir.
any other?
Sir, myself, Prabhu Swami, sir.
Yes, sir. Yes, sir.
Oh, okay, sir. Yeah. Prabhu Swami.
Hello, sir.
Jesus.
Yes, sir. Yes, sir.
Yes, sir.
So nice to meet you, sir.
Thank you, sir.
Long time.
Finally, I should say thank to Professor Suresh for giving this opportunity to share a few information with you. Thank
sir.
you.
Thank you very much,
Nicely
sir.
spoken, sir.
Thank you so much.
Thank you,
Thank you,
sir.
sir. Thank you,
Thank
sir.
you. Thank you, sir. Suresh.
Sir, on behalf of all the participants, I
Yes, sir.
thank Professor Sadashiva for interacting his research, for sharing his research thoughts with you, and hope that all of you have got benefited.
Yes, sir. Yes, sir.
Thank
Okay.
you, sir.
So I thank on behalf of the Academic Staff College as well as on behalf of the participant, Professor Sadashiva sir. Thank you very much, sir.
Thank you so much.
Thank you. Sir. Oh,
Hello, madam. Shall we leave now?
Sir, leave.
Ah.
3:45, sir.
so you have got 45 minutes for tea break.
Yes, sir.
Thank you so much, sir.
Big tea break
Yes, sir.
with high tea break.
Yes, sir.
Yes.